Hello, welcome to my course Introduction to Market Structures. Today we are going to do product differentiation, and we have already done a version of product differentiation while doing Stackelberg price competition. In the Stackelberg price competition, what we have done? We have assumed that the firm 1 and firm 2 can differentiate their product, and that lead to either production of some complementary goods or some substitute goods. I mean, it depends. Now, we are going to do it completely in a different way, and the model that we are going to do is a very famous model, and that is Hoteling's linear city model. So, Hoteling's linear city model is mainly about a location, like think of stretch of a length of suppose unit length, and there are some ice cream parlors. Now, the ice cream parlors, they sell the similar kind of ice cream, but they can vary based on the location in that stretch, okay, of 1 kilometer you can think. So, depending on their different location, what happens, people will go to that ice cream parlor which is nearer to that person. So, that is also a way of differentiating product, or you can say that you have different attributes, and these attributes can be mapped in a distance of 0 to 1. So, it is like it takes a value which lies between 0 and 1. Okay. So, let us do the specific model. So, what we do that what do we assume, that the first consumers are located in a linear city. Okay. So, it is a straight line, and the length of the city is unit length. So, it can be any, but for simplicity we assume that it is unit length, and each buyer buys only 1 unit of the good. So, this is, you can say, it is an example of discrete good. So, here a consumer buys only 1 unit. Okay. And each point in the interval, this unit interval, so it is something like this. So, this is suppose unit interval. Here each point denotes 1 consumer. Okay. Or you can say that the consumers are uniformly distributed over the interval 0 1. So, the distribution of consumers, where each consumer buys 1 unit, is uniformly distributed over 0 and 1. Okay. It is same thing, okay, but this is more technically correct. The consumers are uniformly distributed over the unit length. Okay. Now, suppose a consumer is located at this. So, here it is unit length, this is 0 and 1, and suppose a consumer is located here, this is L star, this point, and buys from a firm located at L I, and suppose this is another firm which is firm I, and its location is L I. So, the utility of the consumer is given by this function. Okay. So, what is this function? This function is this V is the value that the consumer gets from the consumption of this good. So, its value is something like this, that you have a utility function, and in that utility function you plug in the optimal value and you get the value function. Now, here when we say value function, it means because each consumer is buying only 1 unit. So, this is, you can say, is the maximum amount a consumer is willing to pay to buy that unit. So, that is what we mean by the value. Okay. So, this is V, and we assume that V is a positive number. Okay. And again, for simplicity we assume that it is same for all the consumers. Okay. Now, so this portion is clear. When we define the utility, we first define that there is a portion that is the value. Okay. Now, value means the maximum a consumer is willing to pay for that good. and this portion is the distance function. So, this is a kind of negative thing. So, it is a kind of a cost, or you are getting disutility from it. So, the distance that a consumer has to travel from its own location and from the location where the farm is located. So, that distance a consumer has to travel to buy that good. So, that is creating a kind of its disutility, and so it is taken as a cost. Okay. So, or you can say it is the travel, you have to travel this portion, and in while traveling you incur some cost, and that is this cost. Okay. Because this model has been used in many ways. If you study suppose urban economics, how the city grows, how a city grow over time, then also you will find a hoteling model, and this kind of the basic is this model. Okay. And since the consumer gets disutility from traveling, so it is taken as a cost, and so this portion, this V, that what I get from consuming good, or the maximum amount that I am willing to pay minus this. So, this D is the distance that one person has to travel, or a consumer has to travel, and this is given by a function. So, this is the cost, that is the traveling cost, minus the price of the good set by farm I, and that is P I. Okay. So, this is the utility. Why do we need this utility function? You will see why we need. Now, let us define this distance function. So, this distance function is defined in this way, k absolute value of d. Now, here k is the cost per unit of distance, okay, and suppose the distance is d, then it is k into d, and this distance is defined in this way. So, it means that suppose take this 0, 1. Suppose this is the location of a consumer, that is L star, and this is the location of a farm L I. So, then the distance is, you can say d is absolute value of the distance is E L I minus L star, this distance, this much. So, this into k gives you the total amount of cost incurred on traveling, or the utility, disutility that you get from traveling, you can say that. Because this consumer is suppose buying from this, suppose, then you get this much, this small k into this amount of disutility, or you can say it is a cost. And then we specify further, you will see that this k we assumed in such a way that this is V minus P is this amount, k is less than this amount. Okay. You will see why we need to assume this. So, this is one form of distance function, and since distance is always a positive value, so that is why we take it in terms of absolute value. Or you can take another form of distance function, suppose you take the square of this. So, if you take the square of this, it is something like this. Okay. So, the further away, so it is now this is no more linear in this CA. So, if you are further away, then your utility is, this utility is much more compared to when you are nearer it. Okay. Now, this you can think of this linear city model in terms of like this. Suppose you want to buy a product, and that product has some attribute, and that attribute you can give value to it, and you can give value from 0 to 1. And suppose your preferred, your location denotes the attribute that you want, and the location of the farm denotes the attribute that is offered by the farm. Now, if there is a distance, then it means what? That the exact kind of attribute that you want a product to have, that is not being offered. Okay. So, there is a mismatch. So, you get some amount of disutility from it. But if suppose it is matched, so if your location and the location of the farm is same, then it means that the attribute that you want in that product, that same attribute is being offered by the firm. So, it is something like this. So, you want suppose the speed of your mobile phone and you want a specific number to that, okay? You want a specific speed, but the mobile phone companies are not offering that, but it is offering something else. So, the difference between these two, we can take that as a distance, and that distance is giving you some form of a disutility, because what you want, you are not getting it. But if the distance is not there, then you prefer that product most. So, from here what do we get? So, you will buy from that firm which is nearest to you, because that means that that firm is closest to you, and so that firm is giving you that attribute which is closer to the attribute you want, right. But here if you think in terms of attribute as, if you take attributes, see there is again another problem here. So, we have to be very careful. So, like this, so if we are talking about this point as one attribute and this point and another attribute, we do not want to imply that the quality here is better than the quality here. It's not something like that. So, it's simply that it is, we are silent on the quality. What we are saying simply is that these are different nature or different kinds, and the quality of this each kind is same or it is good. Okay? Or simply you can think that when you are choosing from, suppose you are walking in a sea beach and you want to buy an ice cream. So, you will look for that parlor, ice cream parlor which is nearest to you from where you are standing. So, that idea. Okay. So, consumers are going to buy from that firm which is nearest to them. Okay. So, that is why this distance function plays an important role. So, the way we define the distance function, we can vary the results. Okay. Now, we come to the forms. So, we first take the simplest form, and that is we have two forms, two forms 1, 1 and 2. Okay. And the forms decide or choose location in the unit form. So, here in this unit location, there is one location that is chosen by firm 1 and another is chosen by firm 2. Okay. So, firm 1's location is denoted by L1 and the location of firm 2 is denoted by L2. Okay. And for simplicity, we assume that the prices are same, P1 is equal to P2 and it is same. Okay. And it remains fixed. So, the firms in our model, in the actual, the original model Hotling, and that which is further developed in a game theoretic form, that includes this price. So, price is endogenously determined in that model, but that is slightly complicated model. So, since this course is not that advanced course, so we will not take that second stage of the game in this model. We will only consider only this location thing. So, this price we will assume that it is fixed and it is same for each firm. Okay. And further, to simplify the things, we assume that the cost of production is 0 for both the firms. Okay. Now, what is the game here? So, the game is firm 1 and firm 2 simultaneously decides the location L1 and L2. So, in this unity interval 0 and 1, in this interval, firm 1 chooses a location L1 and firm 2 chooses a location L2, and these decisions are taken simultaneously. So, this is a single stage simultaneous move game. So, in this game what do? We compute the pure strategy Nash equilibrium. Now, here the strategy set, you can say L1 is any location between 0 and L2, and strategy set of firm 2 is 0 any point in the this unit interval 0 and 1. Okay. So, this is the strategy. Now, we move to the solution. Okay. So, we find the pure strategy. Now, here let us first define the payoff. Okay. So, profit of firm 1 you can say, suppose, okay, before doing that let us take one. Suppose this is the unit interval and suppose this is the L1 and this is L2. This is the location of firm 1 and this is the location of firm 2. So, the profit of firm 1, so these people are going to buy from firm 1. These people are definitely going to buy from firm 2, because if they move from here to here, this distance is quite bigger than simply this distance. So, this firm people are going to buy from this. So, price is fixed, cost there is no cost. So, it is going to get L1. This is firm, and profit of firm 2, price is fixed, it is going to get 1 minus L2, because this distance any point here, this whole distance is, this is 1 from 0 to 1 and this is L1. So, this is left. So, it is 1 minus L1 this distance. So, this much it is going to get, and it is going to firm 1 is going to get some portion of the people who are located in this region. So, we will get a person like this, suppose L star or L dot or L naught, such that this person is going to be indifferent from buying from this and this, because prices are same, value is same, and if the distance is same. So, this distance must be equal to this distance for this person to be indifferent between buying from firm 1 and firm 2. So, how do we locate this L naught? So, we have to complete this part. So, we have not yet done this. So, L dot is, L naught is such that V minus K L dot minus L1 should be equal to K L2 minus L dot minus P. This is the utility from firm 1, and this is the utility from firm 2. Okay. So, from this we have to find out this L naught. So, this is, you can say, if we do the simple manipulations, we will get this is equal to this, and since the absolute values are, or this modulus are always positive. So, we can say an L1 is, see, L dot is going to lie somewhere here. So, it is, this point is greater than L1 and this point is less than L2. So, we take it this in this form, this distance is this. So, from here what do we get? We get this. So, this L dot here, so this person is who is indifferent, and we have found out the location of that person. Location of that person is this, half of this distance between these two. So, the profit of firm 1 here, it should have been like this plus L2. So, this is equal to what is this? This is L1 plus L2 minus, and profit of firm 2 is this. So, we can say that the profit of firm 1 is and profit of firm 2 is this. Now, the thing is we have to decide the optimal or the Nash pure strategy Nash equilibrium L1 and L2. So, how do we do that? So, we have found this as the given sum L1 L2. Okay. So, let us look at that. Suppose take this example, this case, sorry, not example, this case. This point is the half. Okay. Suppose L1 is here and L2 is here. Okay. Is this any point here lying between 0 and 0.5, any point here lying between 0.5 and 1? Is it optimal? Is any point? So, L1 lying between this point is suppose not included. Now, if we take this case, now think of this situation. Here, fix L2, L2 is somewhere here because we have taken this. If you switch L1 here and suppose the L1 is in this same position here and this is L1. Okay. What is the profit of firm 1? Now, earlier profit of, in this case, profit of firm 1 was this P into L1 plus half of this distance, this half of this, this. Now, if it switches here in this position, its profit is, so this whole is getting now. Earlier only this and half of this, suppose this is the half, so it was getting this position, this much profit. Now, it is getting whole amount. So, what is happening? This gives the profit of firm 1 increases here. So, that is why this is not a Nash equilibrium, pure strategy Nash equilibrium. If firm 2 chooses this point, firm 1 chooses point adjacent to it. Why? Because see, if you look it from this side, firm 1 is the peripheral firm, right. So, firm 1 is peripheral in the left. Okay. Okay, so, there is no firm that is going to lie here. So, if it lies adjacent, this whole portion is going to be its own market share. So, that is why firm 1 is going to choose adjacent to firm 2. So, firm 1 locates to firm 2. Okay. Now, take this case. So, this is L1, this is L2. So, fix L1. Okay. Now, based on the same argument, you will see that if firm, because now what is the profit of firm 2? Firm 2 is this length plus half of this length, which is suppose given by this amount. So, it is this. Now, instead of that, suppose it moves to this position. If we fixed L1, if it moves here, this whole portion is the profit of farm 2. So, its profit now it is P into this distance, this whole distance. So, this whole distance you can say is 1 minus L1, which is greater than P 1 minus L2 plus L2 minus L1, when L2 is this, L1 is this, fixing L. So, this is greater than this. So, that is why again farm 2 here, from this argument you will see farm 2 is peripheral farm from the right. Okay. So, farm 2 locates adjacent to farm 1. So, from this argument we see that the peripheral farms will always locate at, will adjacent to the farm, because this, if you look at this position L1, L2. So, this is peripheral from left, but this is not peripheral from left, this is peripheral from right. So, this farms will tendency will be to move here. This farm which is peripheral in the right will have a tendency to move here. Okay. So, they will move. Now, in this way, what do we see that 0.5, which is the middle center of this unit length. So, L1 will locate here and L2 will also locate here. And so, in this situation what do we get? Because they will always locate at the adjacent position, right. Now, if you take any point other than this, like take L1 here. So, if L1 is here, then from that argument we know L2 is going to be here. So, farm 1's profit is only this much, which is less than half. So, profit is this, right. So, farm 1 if it moves here, it knows L2 is also going to, because this L2 is greater than this here. So, profit of farm 2, this is greater than. So, farm 1 if it locates here, this point farm 2 is also going to locate here. So, it is better to locate here. So, that is why L1 is equal to is this is the unique pure strategy Nash equilibrium, in this case when we have two farms and they decides the location simultaneously, because any point other than this there is a tendency to deviate. Okay. Now, let us introduce one more farm. So, suppose instead of 2 farms we have now 3 farms, and it is something like this. Farm 1 chooses a location L1, farm 2 chooses a location L2 and farm 3 chooses a location L3. Okay. And rest of the specifications are same, that the prices is same, that is P1 is equal to P2 is equal to P3 is equal to P. There is no cost of production and we have one consumer in each point. So, that is consumers are uniformly distributed in the unit interval. Okay. Now, in this setup, see, if we have a situation like this, suppose this is 0, this is 1. So, this is the unit interval. Suppose location of farm 1 is this, location of farm 2 is this, location of farm 3 is this. Now, how do we define the payoff? We will have a person who is going to be indifferent between buying from L1, farm 1 and farm 2. Similarly, we will have a person here who is indifferent between buying from farm 2 and farm 3. So, this location is suppose L dot and this L naught and this is suppose L double naught. Okay. Now, how do we define the profit? Firm 1, firm 1's profit is this people are only going to buy from this firm only, because if they travel to any other firm their cost is going to be higher. So, profit of firm 1, this many people they are going to buy from firm 1 and so these people are going to buy from firm 1. So, that is L naught. This is the profit of firm 1 if the locations are of this nature. And then profit of firm 2 is it is in the middle, it is not a peripheral firm anymore, because this is peripheral from left, and profit of firm 1 is going to get half of this and half of this and half of this, right, or these people. So, its location is L 2 minus loss this plus L double naught minus L 2, and profit of firm 3 which is peripheral from right, its profit is going to be this much. It is always going to get, no one is going to buy from any other firms when firm 3 is located here. So, everyone is going to buy from firm 3 who are lying in this region, and it is going to get this length because this person is indifferent between. So, it is this. Now, we have to find out these two, L dot and L naught and L double naught. So, L double naught is such that V is equal to this. So, from here we get L this again. So, it is going to be center of this length, okay, this. So, exact this much length is going to be how much? So, okay, we will do that. Now, let us first find this L double naught. L double naught is such that L double naught minus L 2 is equal to L 3. So, it is indifferent from buying from firm 2 and firm 3, it is this. So, we get L this is the location of L double naught and this is the location of L naught. So, from here we get the profit of firm 1 is L 1 plus, so it is L dot minus L 1, right. So, this is P into which is equal to and this profit of firm 2 is so this is equal to this portion is this only. So, this is plus here this is L3 minus L2. So, this is actually here this is farm 2's profit is half of length is market share is half of this distance. Okay? Yes. And profit of farm 3 is which is now equal to 1 minus L3 plus L3 minus L2 this. Now, we have to find the exact location of L1, L2, L3. Now, if you take this and suppose this is L1, this is L2 and this is L3. Now, if farm 1 fix these two, suppose L2 and L3 are fixed. So, if it moves here, what is happening? Earlier it was profit is this much plus half of this. So, it is this. Now, if you move, what is happening? Your A is getting profit is going higher because you are getting more length and so your market share is increasing. So, it is best for farm 1 to locate adjacent to farm 2. So, L1 is equal to L2 in this situation. So, that is why this is not Nash equilibrium, right. Similarly, if you look from the perspective of farm, so now suppose L1 and L2, this is somewhere. Let us look at L3, it is here, right. Now, L3, so what it is? This is suppose is got by L1. So, profit of is L1, profit of farm 2 is half of this because this side it is farm 1 and this side it is farm 2. So, it is this L3 minus L2 half of this, and profit of farm 3 here if you look it is this 1 minus L3 plus half of this distance this. So, if so it is getting some this much. Now, if it moves like this then it is profit is going to increase. So, farm 3, so that is why locating here it is not Nash equilibrium. If given these two, if farm 3 moves like this its profit increases. So, that is why it is not a Nash equilibrium. So, from here what do we get? We get that farm, so L1 is going to be L2 from the first argument, and from the second argument we get that this is should also be adjacent. So, this should also be L3 should also be here. So, what that it means? So, given L2, two peripheral forms one and 3 will locate adjacent to farm 2. From one will move from left, another will move from right. So, farm 1 moves from left and farm 3 moves from right, and here we do not get any, because then what is the profit of farm 2? Profit of farm 2 is 0 because it is sandwiched between farm 1 and farm. So, it is here. So, it is sandwiched between farm 1 and farm 3. So, farm 2 will lie here or it will shift to this. So, if it is L1 is this and L2 is and suppose this is adjacent. So, farm 2 will think of moving here or it moving here. If it moves, then farm 1 will be the center, in this case farm 3 will be the center. So, then again it will try to move. So, what do we get? When we have 3 farms and they choose the location simultaneously, then and price is fixed. So, then no pure strategy Nash equilibrium. Okay. So, this is our when we have two farm, we get that it is going to be at the center of the A, and so it results into no product differentiation, right. So, it is the unique, and so it is, since it is going to be at the center. So, in this situation we have no product differentiation, right. Or you can say minimum product differentiation. And here we do not know what is going to happen, because we do not have any pure strategy Nash equilibrium. Now, suppose we have 4 farms, keep everything same, and suppose the location of farm 1 is L1, location of farm 2 is L2, location of farm 3 is L3, location of farm 4 is L4, and they choose from this. And suppose this is L1, this is L2, this is L3, this is L4. Now, from the previous argument, we know here L1, that is farm 1, is left peripheral farm, and L4 farm 4 is right peripheral. So, from the previous argument, what do we get? If L2 and L3 are fixed, here if L2 and L3 are fixed, so farm 1 will locate here adjacent, and farm 4 will locate here adjacent. So, in this case, what is going to happen? Profit of farm 1 is going to be P into L1, this whole distance. Profit of farm 4 is going to be this length. And we have L1 is equal to L2 and L4 is equal to L3. Now, here if you look at what is going to be the profit of farm 2, profit of farm 2 is going to be, so half of this distance. So, this is right, because we will get a person who is going to be indifferent between buying from L2 and L3, farm 2 or farm 3, and we can get this at what point? This is the half of this distance. So, this is going to be this, and for farm 3 it is going to be same this. Now, we can find out what is going to be the solution of this by solving this here. Is it possible to get a solution? Now, see, if this distance is less than this distance, then farm 2 will not lie here, but it will lie right of farm 1, and we will take this. So, that is why this distance must be equal to this distance. Similarly, if this distance is greater than this distance, farm 3 will not lie left of farm 4, but will shift to the right of farm 4. So, from this argument, what do we get? We get that L1 must be equal to this, when L1 is equal to L2, and further we get 1 minus L4 is equal to L3 minus L2 when L4 is equal to L2. right. So, from here what do we get? So, L 1 is equal to L 2 from this. So, L 2 should be equal to this from this here. So, this gives me this, and from here L 3 and L 4 are same. It get this. So, from this what do we get? 2 minus 2 plus L 2 should be equal to 4. So, we have this. This. So, it will go, we bring here should be 3 L this, and from this we have already this here. So, we get L 2 in 3. So, place here. So, it will be 9 L 2. So, this is equal to 2 by 8 L 2. So, L 2 is 1 by 4. So, what do we get? We get here, we get that L 2 is 1 by 4, or what is 0.25. So, immediately L 3 is 0.75, it is 3 times into this, and this is equal to L 1 and this is equal to L 4. So, this is one pure strategy Nash equilibrium. You can take a different also combination of this. So, this is L 2, L 3, L 1 is same, and L 2 and L 4 is same. So, there you can get different combinations. So, this is one pure strategy. So, here if you look at this diagram, it will be like this. This distance is, so this point is 0.25. So, this distance is 1/4, and this is the location of farm 1 and farm 2. This is the location of farm 3, and this distance is again 4th, and this distance is, and this distance is, you can say 0.5 distance. So, they are getting half. Okay. So, this is the one pure strategy Nash equilibrium. So, in this case, when we have 4 forms, we get that there exists a pure strategy Nash equilibrium. But when we have 3 forms, we see that we do not have any pure strategy. And again, when we have 2 forms, we see that there is a pure strategy and there is no product differentiation. And when 3, we do not know what is going to happen. When we have 4, we get that the product differentiation is of this nature. 2 forms are going to be similar and another 2 forms are going to be similar, but these 2 forms are different from these 2 forms. Okay? Or another combination can be this, that is L 1, L 3, this is equal to 0.25, and L 2, L 4 is equal to 0.75. This can be another pure strategy Nash equilibrium. So, this is again a Nash equilibrium. This is also a Nash equilibrium. So, in this case, we get this farm 1 and farm 3 they are similar, but and farm 2 and farm 4 are similar, but these two are different. Here farm 1 and farm 2 are similar, farm 3 and farm 4 are similar, but this group is different from this group. So, this is a kind of product difference. So, we get that there are some forms which are similar, but they are going to be different from the other set of the forms. So, we can go on trying this if we have suppose 5 forms, if we have 6 forms, if we 7 forms, and then we will see get a pattern like this, that the peripheral forms are always going to lie adjacent to their nearest neighbor. Okay? And this we will not go further more than 4 forms, because the calculations are slightly complicated. Even 5-6 forms it is easy, but if you go beyond that, then you will have to solve many equations. So, you can try those on your own, and that is it. So, if you want to read from where this portion I have done, it is from this book Industrial Organization, a Strategic Approach by Search and Ware. These are the specific page numbers 379 to 384, chapter 11. Thank you.